In the past week, Grok, SpaceX's AI offering, was in the news and catching flack again, and you know that's never a good sign. This time, they were uploading users' entire code bases, unencrypted, to SpaceX servers. My unbiased take? Not recommended. In this video series, we're going to take a look at how you can avoid this pitfall by using an LLM running on your Mac to do coding and agentic tasks. We're going to look at some of the best tools to do this. We're going to look at who has the most tokens per second, who has the most models available, who has the cutest avatar. Hey, what are you guys doing, LM Studio? You're competing with like an emo sloth and the world's happiest llama, and then all these awesome dinosaurs. You got to up your logo game. So yeah, we're going to take a look at these offline, private, free options for coding. And we're going to start with Osaurus. I'm not affiliated with these guys, but they just launched on Product Hunt this week. And I'm absolutely stoked that there are free open source options launching on Product Hunt and doing well and getting a lot of engagement. These LLMs have improved in intelligence that you can run on your Mac. If you have 32 or more gigabytes of RAM, they're fantastic options. It's not a drop-in replacement for Claude, and we're going to dig into exactly what they're capable of, what it feels like to use them, and what you should be trying them for. Let's take a look. All right, let's dig in with Osaurus. They are an MLX platform. They have really good macOS integration. And my absolute favorite thing about this is the fine-grained permissions that you can attach to each of the agents that you run. So you have a calendar agent that you've created. You can lock it down so that all it can do is talk to you and your other agents and modify your calendar and your to-dos. Every local LLM app should have the same set of permissions that they do. It's also cool that it's really opinionated. When you install it and launch it for the first time, it identifies how much RAM you have and figures out what you should be running to get the best performance on the system that you have. And while it's opinionated, it's still like super flexible. So let's open it up. And so as soon as I launch it, I've already set it up. I've already been using it. I've downloaded my models. I don't expect a fully local private tool to be going to the internet, but let's see how many it does. So it's connecting to Hugging Face. It's connecting to Osaurus's website. It's connecting to GitHub. It's connecting to GitHub again. And now I am finally done with it trying to reach out to the internet. Another really awesome part about Osaurus is that it's got a server. And if you want to, you can use the agent, like the harness and the tools that you already have set up with Osaurus just running the LLM for you. And I think that's really useful. And this is my preferred way to work with it right now. Overall, I think it is one of the most polished local tools that I've seen in terms of feeling like a native app. It's written in Swift and it feels, about as polished as like the Claude app does to me. Okay, let's perform some software engineering. Let's have the agent write Minesweeper. I'm going to ask for it in HTML, CSS, and JavaScript. Now, this, in my opinion, is the critical flaw in Osaurus for writing software. And what I have noticed is a complete inability for the agent to get stuff out of the sandbox and to get servers running that you can interact with. And we'll see if we experience that failure mode here, and we'll look at the settings available to us. But I think that with a permission system like this, you need skills and context that allow the agent to debug its own running, and I think that's lacking. Okay, our agent is writing the Minesweeper HTML. It looks like it read some files and is writing in the sandbox. This makes sense. It's going to be writing probably a few hundred lines of code, and at 40 or 50 tokens per second output, we can expect it to take a couple minutes to do that. The time to first token is faster in my experience with a local model when the cache is up to date, and the output and generation throughput is a lot lower than what you get running Claude in the cloud in my experience. So something like this, I wouldn't expect to wait as long for this with Claude, but it does get back to you faster a lot of the time. So if we just review the permissions that this blue guy, this coder guy, has access to, it's been given access to this directory. It's called FreshPy agent directory. There's a minesweeper.html file in there and nothing else. It's pretty much empty. It has some tools like the browser that aren't really relevant for this task. It has the ability to use the computer and have AppleScript subagents run, and it also has this sandbox. So let's make sure it has the ability to run a background process and read secrets. And I think what we're going to see is just the ability to write the code and create the Minesweeper app, but then not hand it off and let us interact with it. Okay, great. The diff is too long for the edit approach. This is kind of a bad sign because it looks like it got almost all the way through writing this long file and then it got truncated. And now it's trying to do the same thing again. So it's going through and writing the code for evaluating button presses and initializing the game and stuff. That all makes sense. We'll let it crank for a minute or two. Oh no, it's looping. Twice, our agent tried to write the Minesweeper file, and twice it tried to write too much in one go, and the harness stopped it. The diff is too long for the edit approach. Let me write the entire file at once. The diff is too large for inline editing. Let me write it via Python. And so now it's writing a Python script that's going to write the code for it. Not a good sign. And sometimes a 35B agent can get into a loop like this. Let's, just for a second, I've got a fresh directory down here with no files in it, and I'm going to open up my agent of choice against the same model, Qwen 3.6, 35B A3B. But the one that we're going to be using here is running on a 3090 Ti NVIDIA graphics card upstairs. So again, local AI, but much faster. And because we're using the Pi agent, it has much less going on. It has a pretty open permissions model, and it doesn't have as many restrictions as Osaurus likely has. So let's just give it the same exact prompt. And again, it's an empty directory. The user wants me to write a Minesweeper game in HTML, CSS, JavaScript. Let me create a complete polished implementation. So on the bottom right here, this is running the same model, but again, on an NVIDIA graphics card. And then up here, okay, see, it's already done. Sick. Oh no, it does work. All right, so we can place, and let's make sure that if we click on a mine, great. Okay, so the reason I wanted to run this kind of side-by-side comparison, this is the difference between harnesses, right? So Osaurus is failing here to allow the model to do what it needs to do. It's getting in the way of the intelligence of the Qwen 3.6 35B model to do what it needs to do. And so it's going in loops trying to write a file that allows it to write the code. Pi, which doesn't have the restrictions and doesn't have the flexibility in terms of restricting the agent from doing stuff, it just let the agent rip. And you saw how in just a few seconds there, it was able to write the Minesweeper app. So in my opinion, this is a critical limitation for Osaurus. All right, so earlier we said that there was one configuration option that was kind of a critical showstopper blocker for doing productive work with the LLM in Osaurus. And I think what saves us is the ability to use Osaurus as a server. And so here I can see the URL for the server that's running and powering Osaurus. And we're going to use this with the tool that I already have configured, which is Pi, to do the Minesweeper task that we tried earlier. And by the way, in the several Minesweeper attempts that I made, which the model is fully capable of, shortcomings of the harness and with the Osaurus app stopped us every single time. And so you can see the agent looping in this case. It's already written the code, by the way. It's trying to open it in my browser. It's trying to get out of the sandbox and share the code with me, and struggling with that several times in a row. But here we have a Pi agent running against the Ornith model. So again, it's a Qwen 35B, but this is the recommended model from Osaurus. So I'm going to ask it to do the same task. Now again, the data path here is going directly from my Pi agent to the Osaurus app's backend. And you can use this to use the tools that you already have set up. For me, it's Pi. I love using Pi. And then instead of using Anthropic server or OpenAI server, we're using Osaurus. Okay, so Pi connected to Osaurus running the Ornith model, cranked for about a minute and a half, and it wrote Minesweeper for us. Let's see if it works. It doesn't look right. So if you click an empty space, it should propagate in Minesweeper. So let's ask the agent to correct that. All right. Otherwise, it looks like it's doing okay. So when you click a mine, it does properly end the game. So that's progress. But as you can see, I think the takeaway here is not that there is necessarily a bug in the implementation, but that the harness was getting in the way of this, 35 billion parameter model from doing what it needed to do and write files. And when we went to a more minimal harness with Pi, running against the same internal model, the same server inside Osaurus, it worked fine. On that note of intelligence, on my personal benchmark, which is, held out, it's not in the training data, it performs a tiny bit better than Qwen 35B, but very similar, and not quite as strong as the 27B variants, but still Ornith is a very capable model. So thanks for following along. I think that there is too much friction in the way of the models, and Osaurus is trying to do too much to hold them back, and they're not able to bust out of the sandbox and share results with the user. It means that right now, I don't see how you can use this beautiful UI that has a lot of features I really want to do actual software engineering. The Osaurus backend works great. We used it to write Minesweeper. This app does way too much network chatter before I ask it to. I expect a local private tool to not go reaching out to other servers before I ask it to. That's a personal thing and my preference, but I hope to see the amount of network chatter calm down and not be requesting from 5 different servers on launch when everything's already downloaded and set up. Thanks for taking a look at Osaurus with me, and we're gonna, in the next video, examine another one of these tools. Download it and let me know what you think.